And this really in itself inspires me to come back, because I don't want this year to be the very last time the stream flows on Glacier Creek are ever measured with Dana Glacier as a contributor. I hope that I can return with students from my school, scientists from the Mona Lake Committee, and really continue to do this work because it's incredibly important that we bear witness to this event and see the direct effect that our actions are having on our world. And this isn't just happening at Glacier or Dana Glacier, it's happening at Lyell and McClure glaciers in Yosemite. It's happening all over the world. The Alps, the Andes, the Himalayas. Some of the main water resources there, the Indus and Ganges rivers, for example, a significant amount of stream flow is glacial melt. And that source of water is going to be drastically reduced when these glaciers disappear. That's why it's so important that everybody become aware of it right now. Because currently, we have developed cities and communities based on this source of water. Hydropower, their own drinking water is dependent on this source, and it's going to disappear. So my project is so important because we all live in the Sierras. We're seeing these effects in our backyards. It feels far too close to home. So we often ask, okay, what's left that we still can do? And the answer is this. We still have the Sierra snowpack. This is a vital water source. It provides 60% of California's clean drinking water. But studies show that if we do nothing to slow down climate change, this vital water resource will have reduced by 60% at the end of this century. Think about what that means for the places that have come to depend on that source of water. But it's not too late for this snowpack, because if we take necessary and immediate actions to curb our carbon emissions, we can create a future where we still live with the majority of this vital water resource. Thank you.
High school? I think we have time for a couple questions for Ellery, if anybody has one. I think you said it all, Ellery. Ellery will be happy to talk to you during the break. And she also, her poster that she displayed in the science fair is right behind the doors, behind Kurt. Raise your hand, Kurt, on that. Behind that door, you can check it out during the break. Thank you, Ellery, very much. Okay, you ready to go with Connie Millar, Deb? Here we are, the GLORIA program. So Connie is from the Forest Service. She's also one of our own in Mona City, and Connie's participated in every one of our climate seminars, and we're thrilled to have her back again, talking about measuring the effects of climate change on high elevation alpine plants.
Thank you, Janet, and thank you, all of you. I'm so impressed. It's just remarkable what you've done, and gives me a lot of hope. It also gives me a lot of intimidation, too. I will hope to represent the Geyser cohort and see what we can do. Janet asked me, and actually, Janet, I wanted to congratulate you and all of your climate action people. Thank you so much for all that you've done. It is remarkable, and I know that there'll continue to be more actions, so this is great. Janet asked me this year to talk a little bit about the GLORIA project, and that is an international program that it looks at the effects of climate change on alpine plants. And alpine refers to the area above the tree line, so it's that highest part of the mountains. And GLORIA stands for the Global Observation Research Initiative in Alpine Environments, and it's based out of Vienna, Austria. And we participate in that program here in Mono County. So I hope to summarize a little bit about that. First, a little bit of history. We might ask, why focus on the Alpine region? And there are several reasons. First of all, the highest mountain area is experiencing the most accelerated warming. So things are happening faster, high elevations than in the mid and the low elevations. And from the plant and animal side, plants and animals in the alpine zone are especially adapted to that stressful environment. And so they're particularly sensitive to warming. And when they feel the heat, they will, we expect, want to move up as the temperature zones move up the mountain. And because of the geometry of mountains, they have no place to go, so they would be going off the top, and we'd be losing that particular diverse adaptation. So there was a real interest to focus on that alpine zone. And in the early 1990s, Harry Powley who was a PhD student. He is currently the director of the GLORIA project. He was a graduate student of Georg Grabherr, who was the key Alpine botanist in Austria. And for his dissertation, he investigated studies that had been done in the late, I guess they weren't really studies, they were observations that had been done in the late 1800s in the Alps of Austria. And they had focused on plants that were there then. And Harry went and he looked at the plants that were there now. He found there were big differences, and he found that there had been about a 3-foot rise in elevation of the plants in the Alpine zone in Austria. And there was about, they calculated about 1.5 degrees Fahrenheit change in difference over 90 years of warming. So they thought this was pretty interesting, and that was what started this GLORIA program in the late 1990s. They thought, we need to find out what's happening in the rest of the world in the Alpine zones. Is it similar to what we've seen there? And so they decided to set up a program that would measure around the world. And how they did that, the design that they came up with was, well, first of all, they started with a group, they invited a select group of Alpine botanists from around the world. They locked them in the room, and they said, you can't come out until you've developed a consensus design that is cheap, that is easy to install, that doesn't take too much technical knowledge, and that can be done from the equator to the Arctic area. And so they wanted it to be relatively cheap and low tech so that it could be done in developing countries as well, and so that it would keep people, so they wouldn't rely on a lot of money to do that. So they came up with a design that's based on this target region concept, multi-summit approach, and each target region is in one bioclimatic area of the world, and it comprises 4 different summits. The plots are put on summits from the lowest elevation summit is chosen to be right at tree line, and then 3 summits are chosen above that to the highest elevation where plants grow, which is called the nivel zone. And then there's this giant manual. It's a little intimidating, but once you dive in, it's pretty straightforward. And there's this regular set of measurements that are done on each of the 4 summits. And so it's basically just strings and nets and people going out and measuring, and it does take some Alpine botany knowledge, so we always rely on a few really key botanists to be along. So this is vascular plants that are being looked at. There's also temperature being measured that I'll talk about, and resurveys are done at 5 years. And we might also ask, well, why these summits rather than maybe down on the slopes? And the idea was that on mountain summits, they're sticking their noses up into the regional climate, so they don't experience as much local effects like inversions or cold air drainage. So they're really sensing what's happening in the region. So that was why summits were chosen. And they also are these looking for as much as possible this very regular conical effect. So the key here is that there are very regular protocols that everybody, all of us, are doing. And that makes it easier to analyze across the different target regions. In 2002, I was invited to a workshop in Entlebuch in Switzerland. And at the time I was there, I learned about the GLORIA project. And at that point, it was very strong in Europe, but we didn't have any target regions or any representation in North America. So my colleague Dan Faegre, who is a USGS climate scientist, he works at Glacial National Park, and I came home and we decided we needed to start a chapter in North America. So we did that. And in 2004, we installed the first 3 target regions in North America. And Georg Grabherr and Harry visited us the May before. And you can see it was a snowy year then, like it is this year. And I think Deanna Doolin and Wangdawa Sherpa are in the room. Do you remember this being here? This is on on Gaylor Peak above Tioga Pass. And we were looking for summits and what might be a good choice for the different summits. And we took them up to the White Mountains, and that's the Barcroft Field Research Station, and it was pretty nasty weather. So Dan Faegre established a target region in Glacier National Park that's still ongoing, and I'll just show you the 4 summits. They're much more difficult to access than our summits in the Great Basin. They take a backpacking trip just to get to each one of these summits. So from highest to lowest, there's 2 of their summits, and these are 2 of the lower summits. And I want you just to remember this number of species that they counted when they first installed this in 2004. And one of our first 2 target regions installed is right in our back door here on Mount Dunderberg, and 3 of the summits are marked here. We don't choose the summits that are visited by people because then the plants are trampled. So we're trying to stay in undisturbed areas. And the 4th summit is behind me in the picture here. We have been very lucky to have lots of volunteers, and I would encourage any of you who are interested to talk to me about that. We really do this entirely on the heels of volunteerism, and you're all very familiar with how that works. We've had volunteers from the Mono Lake Committee. This is one of the interns, I think in 2004, and from the California Native Plant Society. Here, Hari and Ger came out again to direct us, make sure we got everything spick and span the way the protocol should be. And on here are more of our summits in the Dunderberg region. And we measured, you'll see that our number of species was only 65. So that was less than half that they had in Glacier. And this probably has to do with it being a relatively arid area where things are there just isn't as much space for and water to uphold more species diversity. In the same year, we established the first target region in the White Mountains. And if you've traveled to the White Mountains to see the bristlecones, you know there is a lot of the limestone and dolomite outcrops. But we decided to put the first target region there. We now have one on the dolomites, on the silicates. So these are the non-carbonate soils. And the highest summit is in fact White Mountain Peak. Here it is again. And then Mount Barcroft. And this is a peak in the McAfee Research Natural Area. And this is the lowest peak on Seychelles Summit behind the Crooked Creek Research Station, where we use that a lot for our evening work. And there we had only 51 species that first year in 2004. So even more arid environment, thinner soils. This is just pretty much what we might expect. So here's the global network today. There are about 140 target regions globally, and we're really thrilled that we have as many as 32 in North America. You can see they're pretty representative. Some of these places where some of our high schoolers are going to be going out that direction, and maybe we need some more established out there. So in this area now, the Great Basin target regions are managed under a nonprofit called GLORIA Great Basin. And we have 8 target regions established now in addition to those 2 I mentioned. And the first dates here are the establishment dates, and these are the resurvey dates. So they go from Panamint Range down near Death Valley, several in the Sierra, Sweetwaters, the Carson Range, which is at the south end of Tahoe, and 2 in the White Mountains, and 1 in Great Basin National Park. A little bit of the early results for this, and the Europeans have been far ahead of us. They looked over 7 years and found these basic results. That as expected, perhaps, species richness has increased with warming. And we might expect that to happen because the warm adapted plants are coming up and mingling with the alpine adapted plants. But interestingly, they found that only in the mid to high latitude target regions. So from around the northern Alps up through Scandinavia. In more of the Mediterranean regions, they found the opposite, that species diversity, the number of species, was actually decreasing with warming and drying. And they think drying is especially important in those already dry and warm areas. And so in this situation, the alpine species were actually being lost. So there had been a few species lost from the summits, and nothing was coming up from lower down. They also found this, what they call thermophilization, which is sort of the effect that happens when there's more heat. And in the European target regions, that was expressed more as not just species, more species, but spreading out more. So what had been relatively sparse earlier, now there were carpets of plants in the alpine zone. And then what's a pretty expected result was that north aspects, results differed by aspects. In north aspects were the slowest and the fewest changes. It's cooler there, so that kind of makes sense. From North America, we haven't been as much advanced in doing the analyses. That's really what is on the table for us in the coming years. a little peek at what Dan Fagry did with early results from Glacier National Park. These are the 4 summits from the lowest to the highest, and number of species out here. The blue bars are after 6 years what they measured as increases in species at each of those summits. The red ones are the decreases. This is the net change. So there's a lot of action going on here, and here's the highest summit, and they just lost 1, I think, and gained all of those. So lots of changes that they were measuring, and so that made it seem, yeah, this is really interesting to see what's happening in just such a short time. We haven't done a real quantitative analysis of the Great Basin sites, but just from being out there every 5 years and looking at the species list and such, we've seen very little change. Not much change in diversity. It's the same species list that we go through each time. But I mean, really, this is the way we're familiar with our summits, right? They're pretty rocky. So we do a lot of counting of scree and rock. These arid mountain regions, they have long life species. It's sparse. Things just happen very slowly. But we'll have to do the statistics to see really what's going on, if much of anything. We did notice after the 2 droughts that we had that there was some mortality of some of the longer lived cushion plants, the little low alpine plants like prickly phlox, and maybe you've seen this on your climbs that these crowns died. But when the conditions got better, the crowns resprouted, and so that didn't really affect the change in cover at a net level. Now, one of the reasons might have to do with temperature change. I mentioned that temperatures are also measured as part of the GLORIA protocol. And we put these little data loggers, they're called tidbits, in, and at each of the 4 summits, 1 tidbit is put on each of the 4 aspects. So there are 16 temperature data loggers for a target region. And these are remeasured every 5 years when we go back to look at the plant change. And we're just working these data up, so finished some of this just days ago. And I'm completely confused by the results, so forgive me if I haven't digested this yet. But what we're finding is that and I meant to tell you, the measurements are every hour, so they're recorded every hour, and then we download those at the end of the 5 years. So what we do see as far as statistical significance is increases in the mean winter temperature of about 0.3 degrees per Fahrenheit per year, which is actually a fair amount. But if you look over the whole year, due to the ups and downs over this 10 years, we don't see any significant change, which is a big surprise to me because I've been measuring temperatures around this region for 25 years, and things are going up in other places. And this is where we thought, on the summits, we would be seeing the most change. So the data loggers are buried in the ground, which is a typical way to measure air temperature, which buffers the extremes. It's not a snow cover issue. So obviously the winter temperatures wouldn't have much effect on the plants unless it has to do with delaying the snowmelt into the summer. So I'm thinking again about reasons why we might not have seen changes in our plant data. We found the same thing for the White Mountains target region. In fact, the same number in winter as well, and no changes in the mean annual temperatures. So that's curious, but it might have an explanation, again, on why we haven't seen much changes in the plants. So that's just to eyeball what the temperature data look like, to give you an idea of the lack of trend. What this is, there are 3 of the 4 aspects at Mount Barcroft, which is in the White Mountain target region. This is going from 2004 to 14, so 10 years of data. So these are hourly data profiles, and this is the winter, proceeding through the winters, and these are the summers data, and you can see, just eyeballing it, it's not a lot of change. We need to get more on the ball, doing more analyses, both for our target regions in Great Basin. It takes a certain kind of statistical knowledge to put all these data together. But we also have been shopping this around to try to do a North American analysis, comparing it to what the Europeans have found, and so our hypotheses take off of what they have found. And the first is that temperatures have increased over the past 15 years, and now we have these data that suggest, I guess maybe at least in the 2 that we've looked at, that's for some reason or other not happening as much. Of course, we'll look at all of the target regions. The second would be the changes in the species numbers and the way the vegetation communities are cover and diversity. Those correlate with the changes we might see in temperature. And then we're wondering whether in North America, we might have regional differences because we represent latitudes from mid-latitude up through Alaska. And then also, of course, we have the lower latitudes in the Mediterranean climate. So they may be different than across the different bioregions. In addition to the sort of bread and butter analyses that are done, the GLORIA project allows for what's called a master station idea. And in the White Mountains, we have a master station, a GLORIA master station, and that's thanks to the support of the White Mountain Research Center. And the idea here is that in addition to those GLORIA studies, surveys that I just described, that other people with doing other kinds of mountain climate science projects would do them together in the same areas in the same time, so we have added value. We know what's going on with plants, and then others can add in their pieces. So we all join at the same time of the year that the GLORIA surveys are being done. And I'm working on American pika. Jeff Holmquist and Judith Schmidt, who are with the White Mountain Research Center, UCLA, do meadow arthropod monitoring. Some groups are working on downslope surveys, so looking at the plants that are below the GLORIA summits to see what might be coming up. And then there's an annual butterfly count. There are many other studies. This is just a little sampler. So whether it's those main GLORIA surveys or the master station, we have a lot of fun. We drink a lot of schnapps and probably lemonade for others. We really enjoy having the volunteers. Again, if you're interested, we're pretty booked for this year. But if you'd like to work with us in the future, it's a lot of fun and a good way to learn your alpine plants and hang out on a summit for the whole day rather than just going up and signing a register. Thank you.
Question, Jeff?
Arthropod monitoring looks like it involves some kind of large vacuum.
They're vacuum cleaner. Yeah, they do. They scoop them up that way, and then UTA gets to sort them out and identify them. They think they developed it themselves, so it's a pretty ingenious method. Yeah, Caitlin.
Do you guys know anything about the temperature patterns of the observatory?
Yeah, those are all well known, and in fact, the temperatures did increase quite a bit, as they did in Glacier. So, yeah, it's very odd. So maybe we will have some more to the story.
Ellery, that's a science project for me.
Yeah, right. Whatever. Great. Thank you all so much.
Okay, I think we're going to try to get Raejean in. One last hand for Connie. Don't worry, we're getting to the break, but I'd like Raejean to have a chance to speak before, because we have this incredible display of Teslas and Priuses and who knows what else is out front. So during the break, we get to look at all the cars, and I'm really pleased Raejean could be here today with us. She's the president of the Electric Auto Association, and she's going to tell us all about electric cars.
Thank you, Janet. What an awesome community this is, working on climate change, and what a fine group of young Americans who went to Washington. I just have to share one fact I found out from a documentary I saw at Sierra Club, which is, while there's so much that's discouraging, this fact is encouraging. How many of you are baby boomers? Okay. How many of you always felt empowered, you know, that we were such a block of voters and we had power, right? Guess what? It's about to change, because the data I found out is that this young generation can outvote us. And we are so proud of them. Now it's your job to go out there and tell every 18-plus-year-old to vote and get to the polls, because that is a job we need to work on. Okay, so who I am, I'll go over that, but before I start, I want to recognize a very important person in this room who has been a leader in electric vehicles. He's the person that I inherited my role from, and just a tireless worker for promotion of electric vehicles across this country and across the globe. He is Ron Freund over there. Ron, raise your hand. 17 years of being chairman of the board of Electric Auto, entirely volunteer. So we're going to talk about Electric Auto Association, who we are, what we do, why it's important. And I like to start introducing myself, not about any credentials I have, education, etc., but my electric car career history, which started with this great car. It was a Kia Soul, and oops, I went too far. It went 93 miles, all electric. I paid $33,000 for it, but the effective cost was $23,000. I got $10,000 worth of incentives, so that brought it down to very affordable. I ran it all over San Diego and just loved that around town car. I needed a car to go to the Sierra, and that car was not going there with 93 miles of range. I had a Lexus SUV, which actually, I'm ashamed to admit, I did love that gas car. And then I started driving around the little Kia Soul and seeing how clean it was, how peppy it was, how I could beat people off the red light. And I started falling out of love with my Lexus. And I said, okay, how can I work this so that I can have an all-wheel drive car? So I traded in my Kia Soul and my Lexus, and I got this beautiful Tesla Model 90D. So the D means all-wheel drive, and I can get up to the Sierra in that, and it has 289 miles of range. Then with my advocacy work, I realized coming up to the Sierra that we are a place, the land of the trucks. And we've got these GMC big Yukons and everything else, and people are loading their bikes and their canoes and everything, and we seem to need these trucks up here for all the recreation that we do. And I found this year that there was a new car that came out. This is the #1 selling PHEV crossover in the world. It's called the Mitsubishi Outlander PHEV. Its cost was about $32,000 after incentives. And so I wanted, this car is a PHEV, plug-in hybrid electric vehicle. Everybody knows it goes about 300 miles of gas, but then 25 miles all electric. Perfect for Mammoth Lakes, which is only 5 miles around. So with, your 25 miles all electric, you're driving all electric around Mammoth Lakes, aren't you? And then when you need to go to San Diego, go to LA, go wherever, you have all that range and you can use the gas. So that's my history of electric cars. I actually did have a business career before my volunteering. I was 23 years in staffing with my own firm, and in my retirement decided to give back, and largely through the environment. So I have 9 years of nonprofit service. So who is Electric Auto? Electric Auto Association since 1967. Right? So we've been around a long time, before all those production EVs came in. We're a 50-year-old nonprofit with over 50 chapters all across the US and across the globe. And who we are, our members are all volunteer and impassioned EV owners whose knowledge and expertise educates the public, promoting rapid EV adoption. Take a look. Here's our members all over the country. Here's in the globe. Can you believe we have members in Denmark, Egypt, and Ghana? Cool, huh? So it's a global problem. Solution has to be global. So what do we do? Electric Auto educates and advocates for rapid EV adoption. We turn up with our EVs, like you see out here in front of this beautiful place. And we talk about why we love driving electric, and we educate the public. And we also do legislative and policy actions promoting charging infrastructure. And you'll see the impact that we had with the new charger that came out, that is coming to Hess Park. So why are we important? What's with the auto dealers? Why do we need these volunteers out there turning up with their cars? Well, because studies show, much like in solar, that new technologies are best sold by word of mouth. That somehow consumers of a new technology, and electric fuel is new for most people, need that trusted voice, a person who's actively using the technology to be able to be confident. So these conversations, displays, ride and drives result in accelerating EV adoptions. And you see a picture here of one of our volunteers talking to people about their cars. We do this all over the country. For example, our Sacramento chapter does over 60 events a year. That's over one event a week. They're in libraries, we're in National Drive Electric Week, we're in Earth Day events, we're everywhere. And making a huge impact. And that vision of this one-on-one conversation that is so impactful is being fulfilled every day. And why is EV adoption so important? To ask, I'm asking a very obvious question to this group especially. You know this fact. Transportation causes over 50% of global warming emissions. Having said that, what comes out of a tailpipe anyway? We looked into this. I looked into it when I first started getting involved in this work, and that led me to American Lung Association and their research. Here's what they did a research paper a couple of years ago that showed that all of these health damages could be avoided, these health damage annually, by 100% plug-in vehicle fleet in California. Here's what we're looking at. 230,000 acute and upper respiratory systems, lost work, asthma attacks, respiratory ER visits, and premature death. People are dying before they should. And heart attacks. Actually, there's a great advocacy group of doctors in Salt Lake City, Utah, that did a study that compared, they have inversion there, and their air quality is very bad from time to time, and their study showed, they measured how many cardiac events happened when inversion was high, and there was a direct correlation. People were having heart attacks when the air quality got bad. It was very clear, it was significant. So some people say, okay, how green, I want to answer this question for you because we get it all the time. So how do I know the electric car is going to be green if it's not plugged into solar? We know solar, that would be fine, right? That's clean energy. But what about the energy being generated? What about if part of it is coal? How green is it really? Well, the Union of Concerned Scientists study shows that an 84-mile range battery electric vehicle cuts global warming emissions by more than 50% compared to a similarly sized gas-powered car. The other question that comes up, what to do with all the when the batteries are no longer useful? Guess what? I learned that electric car batteries, when they're no longer useful for the electric car, the utility companies are looking at them to store power. They're still useful to be able to store power. And you've heard all the utilities having a tough time managing the grid when they have so much solar power during peak sun time. Well, EVs can be parked, 90% of cars are parked at any one time. So if the EV is parked, it can be storing power. And then when everybody comes home and using all the energy, then it can be released. So right now, they're having to dump a lot of that clean power, which is not a happy thing. So here's their map showing that if you live in California, you would have to get a gas car to do 109 miles per gallon to beat an electric car. Okay, so who's doing that? I don't think so. And the fact is that actually 2/3 of people live in a state where it always makes sense to drive electric from a clean point of view. So electric cars are clean, and it's from, again, the Union of Concerned Scientists, and getting cleaner with more and more renewable energy. And who read about Michael Bloomberg devoting millions of dollars to shut down coal plants? Did you hear about that? By 2025 in 4 states. He's personally funding this, and he is not a Democrat, right? So this is wonderful from a role model point of view. So how are we doing in terms of public awareness and EV adoption, in terms of electric cars? Well, we have had an 80% growth in EV sales this last year, and we total over 1 million cars sold in the United States. Now, having said that, when you look across the country and you average, what is the actual adoption rate? 2 to 3%. Not a lot of electric cars are on the road yet. And there are multiple stumbling blocks and obstacles to that, but setting those aside, and you know what a lot of them are, there's this particular challenge, that the average length of ownership of a car is 14 years. I dare say if I did a little poll in this room, some of you are sitting there with cars you've owned a very long time, that maybe are paid off, right? And you may not be thinking that, I need to spend more money to buy a car right now. And the average, and also the trend is that we are actually keeping our cars longer. So these are challenging things. What did I do? For us to work on. So I want to ask you this question. This is kind of a challenge question. How long will you wait to get an electric car? If you're sitting there with this paid off used used gas car that hasn't given you any maintenance issues lately, can I get you to rethink that a little bit and get creative? You don't get that creative. Just consider trading in your used gas car for a used electric car. This means you might have to get online and look for some used EVs, but there's some great ones available. In fact, you could get a used Tesla for $40,000. You might even be able to find a used Tesla with supercharging free for life if you look really hard. So, and you can get all kinds of very affordable used EVs ranging from 12, like that Kia Soul I had, you can get one of those for 10, 12,000. So, what are the choices available right now for you? I challenge you to have a look at that. Now, it wouldn't be a talk about electric cars without showing you a very quick browse through some of our favorite electric cars. First, you need to get all on the same page. Maybe you are already there. These terms, that battery electric vehicle is all electric, right? And then plug-in hybrid, it plugs in, it's part gas and part electric. So here's a quick browse through some really cool cars. Here's the Nissan Leaf, which the